All right, so you've done the hard work, you've collected all your data, and now you're staring at this massive spreadsheet, just full of numbers. The big question is, where in the world do you even start? Well, today we're going to demystify those essential first steps of data analysis right here in SPSS.
You know, that feeling of just a little bit of panic when you first open up that data file? Yeah, that's totally normal. But think of it this way. Before you can tell a story, you have to get to know your characters. And that's exactly what we're doing today, giving your data its first and most crucial checkup.
You wouldn't want a surgeon operating without checking your vitals first, right? It's the same idea with data. We can't just jump into running complex, fancy tests without first getting a handle on our data's basic characteristics. And we do this using what are called descriptive statistics. So why is this so important? Well, first off, this checkup lets us accurately describe who is in our sample, which is just fundamental for any report. It also helps us spot any potential issues or errors early on before they cause bigger problems. It's all about making sure our data is healthy enough for more advanced analysis so that whatever we find later, we know it's trustworthy. Okay, before we check those vitals, we need to know what kind of data we're actually looking at. Generally, it's going to fall into one of two buckets. It's either categorical or it's continuous. And trust me, knowing the difference is absolutely crucial for picking the right tool for the job in SPSS.
Let's break this down real quick. Categorical data is all about distinct groups. Think male or female, or maybe single versus married. You're in one box or you're in another. Continuous data, on the other hand, lives on a scale. Things like age, height, or score on a test. These can have a whole range of different values.
For our categorical variables, that first checkup is super simple. We basically just want to count how many people fall into each group. In SPSS, we use a procedure called frequencies, and it's as easy as it sounds. You just go to Analyze, then Descriptive Statistics, then Frequencies, and you pop your variable right into the box. And boom, the output table gives us exactly what we're looking for. In this sample data, we can see right away that we have 185 males, which is 42.1% of the group, and 254 females, making up the other 57.9%. Simple, clear information about our participants. Perfect. Excellent. So we've tallied up our groups. Now let's turn our attention to our continuous data. For variables like age or those scores from a questionnaire, a simple count just isn't going to cut it. We need a much richer summary. So this time we use the Descriptives function in SPSS, and what we get is this incredibly useful summary table. It tells us everything from the number of valid responses to the minimum and maximum scores, and most importantly, the average score, which is also called the mean. Just from a quick glance at that table, we can immediately pull out key facts about our age variable. We see the youngest person was 18, the oldest was 82, and the average age is right around 37 and a half. See? This is already painting a much clearer picture of our sample. Now, that summary table also gives us values for something called skewness and kurtosis. Don't let the names intimidate you, okay? Skewness, like it says here, is really just a measure of symmetry. It tells us if our data makes a nice, perfect bell curve, or if the scores are kind of piling up on one side or the other. And in that same vein, kurtosis just tells us about the shape of the peak of our distribution. Is it really sharp and pointy, or is it more flat and spread out? Both of these numbers give us vital clues about the overall shape of our data. This brings us to a really critical diagnostic test. You see, a lot of the most powerful statistical procedures out there assume that your data follows what's called a normal distribution, that classic bell-shaped curve. So we have to check if our data actually meets that assumption. SPSS gives us this handy tests of normality table. Now, the column you want to look at is the one labeled SIG. Here's the rule of thumb. If that number is bigger than 0.05, your data is considered normal enough for most tests. And look at that. Both of our values here are above 0.05, which is fantastic news. But numbers can be a little abstract. I always recommend doing a visual check too. A histogram is basically a bar chart that shows you the distribution of your scores. And right here, we can actually see the shape. And for both males and females, the data is roughly forming that nice bell curve shape we were hoping for. The QQ plot is just another way to see the same thing. In a perfect world, for a perfectly normal distribution, all of those little dots would sit right on that diagonal line. And as you can see here, our dots are snuggling up pretty close to that line, which just confirms our data is behaving very nicely. All right, we're on the home stretch. The final part of our data's health checkup is to scan for any anomalies. We're on the hunt for outliers. These are scores that are either extremely high or extremely low compared to everybody else. They can sometimes distort our results, so we've got to find them. A box plot is my absolute favorite tool for a fast visual diagnosis. That main box shows you where the middle 50% of your scores are. But look closer. Do you see those little circles with numbers next to them? That's SPS visually flagging those specific cases as potential outliers.
Yep, the plot has pinpointed 3 cases for us, the ones with ID numbers 24, 157, and 61. It's telling us these people have unusually high scores on total perceived stress compared to the rest of the group.
And to make our investigation even easier, SPSS also gives us this extreme values table. It literally lists the top 5 highest and lowest scores and tells you their case ID number, so we know exactly which participants to go back and check on. So, you found an outlier. What do you do now? Well, step 1 is always to check for a simple typo. Was a score of 46 actually meant to be a 36? It happens. If the score is genuine, though, you have a decision to make. There's no single right answer, but the golden rule is transparency. Whatever you decide to do, just report what you did and why you did it. And just like that, our data's first checkup is complete. We've described our sample, we've checked our variables, we've screened for anomalies. Our data is now clean, we understand it, and it's ready for some serious analysis. By doing all this, you've built a really solid foundation for your research. You're no longer just staring at a confusing spreadsheet. You're looking at a data set that you actually understand. And now you are ready and empowered to move on and find out what amazing stories your data has to tell.